Hey everybody, welcome back to a one-dimensional kinematics problem. Third example of acceleration, and yep, it's a long one. Okay, so let's just dive right in. A person driving her car at 46 kilometers per hour approaches an intersection just as the traffic light turns yellow. She knows that the light lasts only 1.9 seconds before turning red, and she is 27 meters from the near side of the intersection. Should she try to stop or should she try to speed up and cross the intersection before the light turns red? The intersection is 16 meters wide. Her car's maximum deceleration is minus 5.7 meters per second squared, whereas it can accelerate from 46 kilometers per hour to 66 kilometers an hour in 5.8 seconds. Ignore the length of her car and her reaction time. Okay, so wow, there is a lot of information in that question. Very long. But you know what? We're going to handle it just like any other, and it's not going to be that much more difficult than the other ones. We just have to make sure to break this problem up into appropriate sized pieces and tackle them at each time. Okay, so let's get started. So the first thing I notice anyways when I'm reading this problem is, I've got some things quoted in kilometers per hour. I've got an acceleration, or rather deceleration, quoted in meters per second squared. I've got a distance of 16 meters, another of 27 meters, and then a speed of 46 kilometers per hour. So, and a time, by the way, of 1.9 seconds. So what you've got here is some units that are in SI and others that aren't. Okay, so like the speeds, we would have to convert to meters per second. But in time, we'll do that in time. Okay, so as with any physics problem, the first thing you want to do is draw a picture. So you know what? Because this page is actually completely filled up, I'm going to start this on a new page. Okay. So you have to draw a picture first of what's going on, right? So, and like I mentioned in past videos, your picture doesn't have to be, very artistic. Mine certainly isn't. Okay. From the problem, okay, she's 27 meters from an intersection that's 16 meters wide. Okay, so the front of her car, there's a 27 meter distance. The intersection itself is 16 meters wide. Okay, and the question essentially comes down to this. Can she pass it? Should she pass it, or should she just stop? Okay, obviously we all probably want to pass it, but then the question comes, is it safe to pass it? Okay, so this is what we're dealing with. We have two cases. Case one is stopping. Case two is passing the yellow light. So we're going to tackle these cases one at a time. Okay, so case one is stopping. So pretty much, given her deceleration, given her current speed, can she stop? And remember, we're ignoring reaction time. Okay, so remember, in the problem, we're given her initial speed. She's going at 46 kilometers an hour. So the first thing you have to do is convert that number to meters per second. Okay, so because that's the speed she's going at, and we're wondering if she can come to a stop, that means V initial is her 46 kilometers an hour. And her final speed V is going to be 0 because she's stopping. Okay. Now, like I mentioned in every other video, okay, if you guys want to convert from kilometers per hour to meters per second, you multiply by 1. Anytime you want to change the unit, you multiply by 1. Here, we're changing both the kilometers and the hours, so we multiply by 1 twice. And we write that 1 as a large fraction that we're not going to quite fill in until we know what we're doing. Okay. Now, we want to convert this V naught in terms of meters per second. Okay, so if we're trying to get rid of kilometers, we have to divide by kilometers, because simply multiplying by kilometers will give you kilometers squared. Okay, we're trying to get the unit of meters out, so I put meters on top. So then you ask yourself, okay, what ratio of meters to kilometers equals 1, right? Because this fraction is equal to 1. Okay, well, it turns out that 1,000 meters is 1 kilometer. Okay, so there's multiplying by 1. And again, in case you didn't see the other videos or in case you forgot, we can do this because multiplying by 1 does not change the question. Multiplying by any other number would. Okay, so that deals with the kilometers. Now for the hours, we want it in terms of seconds, right? So in order to get rid of hours, If it's being divided here, I have to multiply by hours here. The unit I'm trying to get out that should be in the bottom in the end is seconds. So I'm going to put S here. Then just like the previous one, you ask yourself, okay, if this entire ratio needs to equal 1, well, what ratio of H or hours to seconds gives you 1? Okay, well, in 1 hour, there's 3,600 seconds. Okay, 60 minutes in an hour, 60 seconds in a minute, and times 60 minutes in an hour. 60 times 60 is 3,600. Okay, so now we can start canceling things out. H cancels with H, kilometers cancels with kilometers. So you're left with meters on top, seconds on bottom, which is what we wanted. Okay, now the way you multiply this across, remember, even though it's written as a whole number, 46 as a fraction, you can write as 46 over 1. And the way you multiply fractions is you do 46 times 1,000 times 1 over 1 times 3,600. Okay, numerators multiply together over denominators multiply together. Okay, it's pretty straightforward. Okay, so when you do this, you're going to get 12.8 meters per second. So she's going 12.8 meters per second. So at this point, ask yourself this. Can a car driving at 12.8 meters per second that decelerates at, so let's write that here, because she's decelerating, she's slowing down. Her speed here is quoted as positive, therefore acceleration must be negative to oppose it. If she's driving at that speed and she's decelerating at 5.7 meters per second squared, can she stop in a 27 meter displacement? Okay, so what I'm going to do, because I know this is V initial, right? Like I mentioned just a few moments ago, she has to come to a stop for this scenario, which means that the final speed is 0 meters per second, okay? So knowing V final, V initial, acceleration, I'm going to actually calculate in what distance she can get to 0 from this speed with this acceleration. If that distance is less than 27, that means she can stop safely before the intersection, okay? If that distance is bigger, that means she's going to stop either well into the intersection or even potentially after, and she should just try to pass, okay? So without further ado, let's actually calculate that out. Okay, so we're going to go ahead and use this kinematic equation, and that is 2AD equals V final squared minus V initial squared. Okay, remember, we're solving for D, the distance. So in order to do that, you have to divide both sides by 2A, right? Because that'll get rid of it on the left. So then on the left, you're left with D equals V squared minus V naught squared over 2A. Okay. V is 0, so 0 squared. V naught we just found is 12.8 meters per second squared. Okay, make sure you write those units. You don't need to write it for 0 because 0 is obviously nothing, but make sure you write it for everything else. Over 2A, the acceleration is minus 5.7 meters per second squared. Okay, so 2 times minus 5.7 m over s to the 2. Okay, it just becomes a mathematical problem at this point. Okay, so if you actually calculate this out, you're going to end up with D equals 14.4 meters, okay? And that is less than 27 meters. Therefore, she can brake safely, okay? So in case 1 that we just inspected, the case of stopping, yes, she can brake safely because according to her initial speed, in order to stop, given the decelerating ability of her car, right? It only takes her 14.4 meters to stop, so she's going to stop somewhere around here. Okay, so she's not even going to get that close to the intersection. Okay, so this is a possibility. She can stop. But can she pass the yellow light? Because, you know, if you could pass it and stop it, most people would prefer to pass it safely. Okay, so let's try case 2 and see if she's capable of passing. Okay. So case 2, passing the yellow light. All right, so here's the thing. We need to know if she can pass the yellow light. In other words, if you look back to the sketch, right, can she cross this distance, right? Now, remember, we know what speed she's going at right now. She's going at 12.8 meters per second, right? Or 46 kilometers an hour, right? Now, in order to pass, obviously she's going to try to, press the gas pedal. She's going to accelerate, which is why they've given you information that allows you to determine the acceleration of the car. Okay, so if you remember in the problem, it tells you, okay, where is it? Here we go. She can accelerate from 46 kilometers an hour to 66 kilometers an hour in 5.8 seconds. This is not telling you the acceleration directly, but it's giving you every single piece of information in order for you to determine it. Okay? If you know her acceleration, and she quotes that it takes 1.9 seconds for the light to change from yellow to red, that means given her initial speed, given the time she has, given her acceleration, okay, what distance can she go within that amount of time? Okay, just like before, if that distance is going to be more than 27 plus 16, she can safely pass. But if that distance turns out to be less than 27 plus 16, I think she should just stop. Okay, so back to case number 2, passing the yellow light. Okay, so here's the thing. Let's find the acceleration first. And like I mentioned in previous videos, acceleration is change in velocity with respect to time. So, I mean, if you know the definition, you don't need to memorize the formula. It's delta V over time, okay? Delta means change, okay? So final minus initial. So that's equal to V minus V naught over T. Okay, so we're going to quote the values of, well, she can go from 46 kilometers an hour, which is V initial, to 66 kilometers an hour, V final, in 5.8 seconds time. Okay, so I'm going to go ahead and write that in. Okay, so V final is 66. Subtract 46 kilometers an hour divided by time, which is 5.8 seconds. Now, you're probably sitting there wondering, okay, she just figured out that this is 46 kilometers an hour is, well, 12.8 meters per second. Why didn't I just plug it in? Well, I'll be honest, the math comes out to be almost the same amount of work because I have to still find the difference. So either way, I'd have to do one more step to find this out. Okay, but I'm going to just do one less step in this sense. Okay, so 66 minus 46 is 20. So 20 kilometers an hour over 5.8 seconds. Okay, now on the side here, I'm going to just convert. Okay, so let's do that here actually. Okay, so aside 20 kilometers an hour. Remember, to get rid of units or to change units, you have to multiply by 1. I'm changing 2 units here, so I multiply by 1 twice. Okay, I'm trying to get rid of kilometers. I'm trying to make it meters. So in order to get rid of kilometers, you have to put it in the denominator, right? Because if you multiply kilometers times kilometers, it's kilometers squared. Okay, the unit that I'm trying to get out, I write on top, which is meters. Okay, so then ask yourself what ratio of meters to kilometers is equal to 1. Okay, and we know that 1,000 meters is equal to 1 kilometer. And for the next part for hours, okay, this probably should be fresh in your head because we just did it a few seconds ago, but we're trying to get rid of hours, so we write it on top, so it will cancel out with the hours here in the bottom. We're trying to get the unit of seconds out. You then ask yourself, well, what ratio of seconds to hours equals 1? Well, there are 3,600 seconds in 1 hour. Okay, thereby canceling the kilometers, cancels the hours. Okay, and you're left with, if you calculate this all out, you're going to get 5.56 meters per second. Okay, so with that number in mind, I'm going to go ahead. 5.56 meters per second divided by 5.8 seconds. Seconds are going to cancel out, and you're going to be left with an acceleration of 0.958 meters per second squared. Okay, so In case you missed what I said earlier, you might be wondering why find the acceleration. Well, you're given her initial speed. Remember, it's 12.8 meters per second. Okay. If you know her initial speed, you know how fast she can try to speed up the car with the acceleration. You know that the light is going to go from yellow to red in 1.9 seconds. And you know that she has to clear a distance of 27 plus 16, which is 43 meters. Can she clear 43 meters? Well, that's what we're going to find out. Okay. So we're going to calculate the distance that she can pass. Okay, so let me just draw a line there. This is a separate calculation now. So let's use this kinematic formula. D equals V initial times time plus 1/2 acceleration times time squared. Okay, so V initial, 12.8 meters per second. She's got 1.9 seconds to cross, plus 1/2 times the acceleration, 0.958, the one we just calculated, meters per second squared, again, times 1.9 seconds squared. Don't forget that too. Okay. So make sure when you're entering this in your calculator, I mean, you could probably do it in one fell swoop, but if you want to just avoid that small possibility of error, just enter this in your calculator and enter this in your calculator, because this is going to be a product overall, and then the sum of the two products. Okay. You have less chance of messing it up if you do it separate. Okay, so if you do it separate, you're going to get 24.282 meters plus 1.72919 meters. Okay. If you add those two together, you're going to get that D is approximately, well, if you round it to sig figs, right, we can only give up to 2 sig figs in this question, we get 26 meters. Okay, so now, again, here I come back with the original question. She can go 26 meters, right? She can accelerate 26 meters. That means she's going to be right about, whoops, sorry guys. She's going to be right around there when the light hits red. So she should not try to pass. Even if she speeds up her car to the maximum extent, she will not even come to the start of the intersection. She's going to be at 26 meters, which is right there. Okay? So the way we want to phrase this is D is approximately 26. This is much less than 43 based on our context. Therefore, she should not pass and should stop. Okay. So there you have it. Okay. Make sure that you calculate both ways. Simply calculating case one, that she can stop safely, is not enough to answer the question, because it's asking you, to prove it, right? I mean, if she can stop and she can pass, most people would pass. But she clearly cannot pass. She cannot even reach the intersection, but she can stop pretty safely. Okay, so wow, that was a long problem, guys, but good for you for hanging in there. Like I said, it seems long. I think the longest part of this problem was just the question. Okay, if you just break it up into easier, more manageable parts, it makes a lot more sense. Look, a lot of the question broke up into things that we are already used to seeing, like acceleration, or here, this kinematics formula. So stuff that you're used to and probably comfortable at this point doing. Okay, so that's it for this video, guys. If you liked it, if it made sense to you, I hope, make sure to give that like button a click. Consider subscribing to my channel. Just hit that subscribe button below the video, okay, so you can stay tuned for other physics videos from me. Okay, I'm going to be solving a whole lot of other problems. I'm going to be posting frequently, so you guys stay tuned, all right? If you think there's someone who can benefit from this, be sure to share it with them on Facebook or on Twitter. And other than that, I will see you guys later.